Alright guys, today we're going to solve a calculus problem from chapter 4. We're going to find the area under this curve of the sine function as shown in problem number 51. Using the fundamental theorem of calculus we see here with the antiderivative, and also we have to know that in order to solve this, that the integral of sine is going to be negative cosine. These are the integrals and derivatives for trig functions we have to know. So to start off, I'm just going to say the area is equal to the integral of the lower bound. Sine starts at 0 in this diagram, so at the origin, so we have 0 for lower bound, and it goes in the figure to 2. Okay? Those are our limits of integration. Alright, then we're going to have our function, which is sine of x, and then dx. Okay? And then that tells us we're integrating this function with respect to x, this dx term here. Alright, the antiderivative, or the integral of sine, we know is negative cosine. So we get negative cosine of x bounded from 0 to 2. Okay? And now we just use our equation here from fundamental theorem of calculus. We know that the antiderivative is negative cosine. It goes from 0 to 2. So it's going to be negative cosine, substitute in 2, okay, for this upper limit, minus, this minus here is this minus sign right here. We have f of a, which is going to be, in brackets, negative cosine of 0. Okay? Now, we know cosine of 0 is 1. Cosine of 2 is going to be an irrational decimal number because we know we're dealing with the unit circle in radians. So, I'm just going to say that this area is equal to negative cosine of 2, which we'll leave as a number in that form for now. And then minus makes plus. Cosine of 0, we know from a unit circle, cosine of 0 is 1. So we have 1 minus cosine of 2 essentially. So we can go to our calculator now if we want a decimal number. We can do 1 minus the cosine of 2, make sure we're in radians as we are. And we get approximately 1.416. Now this is not the square root of 2. It's close to that, but it's not quite the square root of 2. We can check this in the calculator. We can check our answer by simply going to math, and then option number 9, FNINT, for the integral function in the calculator. Our original integral was 0 to 2 of sine dx, so we have 0 to 2 for our limits of integration, sine of x, and then dx. Okay, and we can see the same answer here. If we subtract them, if we want to just double check, we can see that we will get indeed the same answer. So when they subtract their 0, so this is our area under the curve in exact form and an approximate decimal. Okay.